IGCSE plate tectonics. So, the structure of the Earth. The Earth is divided into four main layers: the crust, the mantle, the outer core, and the inner core. So, the crust, as you can see on this diagram, the outer thingy here, well, it's solid and it's the layer that we live on. The crust is usually between 10 kilometers and 60 kilometers thick. The crust's thickness is often referred to as the relative thickness of an apple skin when compared to the size of an apple. Mantle, right here, that orange part. This is the thickest section of the Earth with a diameter of about 2,900 kilometers. The mantle is often described as being semi-molten, but in reality, the top is hard rock, and as you near the outer core, it is beginning to melt, so it's becoming magma. Convection currents are found in the mantle. The outer core, here this kind of light orange thing, it's the layer believed to be liquid, and it's largely made of iron and nickel. It's extremely hot with temperatures of up to 5.5 thousand degrees centigrade. Then the inner core, Jesus Christ, what's happening with my mouse? The inner core here, it's believed to be solid because of the immense pressure placed upon it. It contains the center of the Earth, which is about 6.378 kilometers from the surface. It is also extremely hot at about 5.5 thousand degrees centigrade. And then, yeah. Sometimes you will hear the crust, should be AR, the crust and the upper layer of the mantle referred to as the lithosphere. And yeah, below the lithosphere, but also in the mantle, you find the asthenosphere. This region lies between 100 kilometers and 200 kilometers, but you don't need to remember these two terms in your exams. I was just, extra info. Sorry. Tectonic plates and Earth's crust. The crust of the Earth is broken into giant pieces. These giant pieces are called tectonic plates, or often just plates. There are 7 major or primary plates: the African, Eurasian, North American, South American, Pacific, Indo-Australian, and Antarctica plates. There are 7 smaller secondary plates: Nazca, Cocos, Caribbean, Scotia, Arabian, Philippine, and Juan de Fuca. Because the plates are so big, they have faults and cracks in them, so are sometimes divided into smaller tertiary plates as well. The Earth's plates are being constantly moved by convection currents found in the mantle. We will learn next what convection currents are and how they have changed the shape of the Earth. There are 2 types of crust: oceanic and continental. Generally, oceanic crust is found under the oceans and continental under land, so continents. Fairly simple. Although plates are usually a combination of oceanic and continental crust, there are some key differences between the 2 types of crust. These are the key differences. Firstly, the oceanic crust, so where there's the ocean, it's younger, and it's usually thinner, and it's denser, so that means heavier, and it can be destroyed, and it can be created. Whereas the continental crust, so where there's land, it's a lot older than the oceanic one. It's normally thicker, it's usually less dense, so it's lighter, and it can't be created, and it also can't be destroyed. So since the oceanic one is heavier, this one's lighter, the oceanic one will sink. But we'll talk about what this is afterwards. Okay, shifting continents and convection currents. 225 million years ago, all the continents are believed to have been joined together in one supercontinent called Pangaea, as you can see in this picture here. Over millions of years, convection currents started moving the continents apart, until there were 2 continents: Laurasia and Gondwanaland. You don't really need to know that, though. Today, the continents have moved even further apart, creating the land masses that we know today. The continents have not stopped moving, so in the future, the world will look different again. For instance, Europe and North America are actually moving apart at up to 10 centimeters a year, but North America and Asia are moving closer. So, the tectonic plates are now being moved by convection currents found in the mantle of the Earth. Below is a summary of how convection currents work. Firstly, here, look at here, you've got magma in here, right? Well, it's semi-molten rock near the outer core, right? So it's heated, since the inner core and all that stuff, it's really hot. And as the magma warms, it expands and becomes less dense, so less heavy, becomes lighter. So then the less dense magma then starts to rise towards the crust. As the magma nears the crust, it begins to cool. The cooling magma becomes denser, as in heavier again, and begins to sink. And then the rising and falling of magma creates circular currents with the mantle. Because, for instance, look at my mouse here. If it gets hot here, so it goes up, and then it gets cold, so it goes back down. But it's not only happening here, it's also happening here, 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 here. So this does kind of affect the plates that are on top. So the rising and falling magma creates circular currents within the mantle, and these are the currents that create friction with the crust above and cause it to move. This process is known as convection currents. So, plate boundaries. I'm so sorry, I'm just so tired. Where two plates join, it's called a plate boundary. Plates may move towards each other at a boundary, away from each other, or alongside each other. If you look at a map showing plate boundaries and earthquakes and volcanic activity, there's a very strong relationship. Below, we will look at plate boundaries and learn why there are earthquakes and volcanoes found at plate boundaries. Here there are some maps, there is a map showing plate boundaries and earthquakes and volcanoes. So yeah, when you can see that these are all the tectonic plates of South America, Nazca, Pacific, all this stuff. And you can see these little arrows mean in what direction they're going right now. So with the help of these arrows, you can figure out what kind of occurrence is going to occur. So, describing distributions on a map. I'm sorry. When describing a map, always draw a compass next to the map, indicating the 8 major compass points. So north, northeast, east, southeast, south, southwest, west, northwest. Doing this will help you make your description a lot clearer. You should know where the world's 7 continents are. So Africa, North America, South America, Europe, Oceania, Asia, and Antarctica. And the 3 major oceans, Atlantic, Pacific, and Indian. With the 8 compass points, 7 continents, and 3 oceans, you should be able to describe most places on the Earth. For example, if I was describing the distribution of earthquakes, I might talk about the concentrations in the west coast of South America, west coast of North America, the south of Europe, the middle of the Atlantic Ocean, and the edge of the Pacific Ocean. If you are confident with your country knowledge, you can make your descriptions more detailed also by adding the actual country names. For instance, you can say East and Southeast Asia, including Japan, Indonesia, and the Philippines. So now, some definitions. What's an earthquake? Well, an earthquake is a series of vibrations or movements in the Earth's crust. A volcano is a vent, so a hole in the Earth's surface, where magma, and then once it rises, it's called lava, gas or ash escapes onto the Earth's surface or into the atmosphere. Ring of fire. This is the largest concentration of volcanoes, which is found around the edge of the Pacific Ocean. El Salvador is located in the Ring of Fire. Intraplate earthquakes. This is an earthquake found in the center of a plate. Very rare, though. Hotspot. Basically an intraplate volcano caused by a weakness in the Earth's crust or particularly hot magma rising to the surface and breaking through the crust. Hawaii sits on and has been created by a hotspot. So plate boundaries. Plate boundaries can be classified in several ways. Plate boundaries where plates are moving towards each other are called convergent because they're converging. Plate boundaries where plates are moving apart are called divergent because they're diverging. And plate boundaries where plates are moving alongside each other are called transform. No, that's not right. Are called conservative. Sorry. However, at IGCSE, we need to know the specific names of the plate boundaries. You need to know 4 types: constructive, destructive, collision, and conservative. So let's have a look at constructive. So think at a constructive or divergent plate boundary, 2 oceanic plates are moving apart, so they're moving away from each other. And constructive plate boundaries are found under the ocean, for instance, Atlantic Ocean. and can cause the process of seafloor spreading, basically the ocean floor getting wider. The movement apart of the plates allows magma to escape from the mantle below. When the magma touches the ocean, it cools and forms new land, creating an oceanic ridge. The world's best example of an oceanic ridge is the Mid-Atlantic Ridge. Over time, ridges can break the surface of the water and form new islands, for instance Iceland. Because the plates are moving apart, there is not a large build of friction, so earthquakes tend to be fairly gentle. Volcanoes tend to be less violent than at a destructive plate boundary, but can be more constant. Volcanoes can also cause problems of lahars in Iceland. This is basically the lava melting the snow above and causing a mudslide. So quick summary, the way I remembered is if you think constructive, this is when you want to help. You don't want to be mean, you want to be good. So these two plates, they don't want to collide and have confrontation. No, they're being constructive, so they decide it's not worth the argument, so they just kind of move apart, okay? They move away, so they're being constructive. And then since they move away, it leaves a hole, so then the magma from the mantle rises and turns into lava, and then when it meets the sea, it cools, so then there's land formed. Okay, destructive plate boundary. Sorry. A destructive or convergent plate boundary is when oceanic and continental crusts collide. The denser oceanic crust is forced under the continental plate, so it's subducted. Because it's heavier, the oceanic one is always heavier, so it goes down. It subducts. Huge amounts of heat from the mantle and also the friction cause the oceanic plate to start melting in the subduction zone. The continental plate cannot be destroyed, so it's forced up to make fold mountains, for instance the Andes in South America. And as the oceanic plate melts, it expands, becoming less dense. This causes some of the magma to rise to the surface through the fold mountains, creating volcanoes. Where the oceanic plate subducts under the continental plate, a very, very deep ocean trench is created. This is basically a deep valley in the sea. Ocean trenches are the deepest sections of the world's oceans. Big earthquakes are found at destructive plate boundaries because of the buildup of pressure between the two plates. If a destructive plate boundary is found at sea, the continental crust, or the less dense oceanic crust, is forced up to make an island arc instead of fold mountains. There are many examples of island arcs around the world. So, basically what happens, there's the oceanic crust and the continental crust. The oceanic crust is denser and heavier, so it subducts. And then, so once it subducts, since there is lots of heat down here from the mantle, also the friction of when it moves in, this means that the oceanic plate starts melting in the subduction zone. So this part starts melting. And then, so this part, the continental crust can't be destroyed, so instead, since there's now more, let's say, submatter in here, it makes it rise, creating fold mountains, and And this causes, some of the magma to rise to the surface through the fold mountains, which will create a volcano. So a collision plate boundary. A collision or convergent plate boundary happens when two continental plates collide. Because neither plate can be destroyed, they are forced upwards and downwards. The upward section make fold mountains, like the Himalayas, and the downward section makes mountain roots. You get big earthquakes at collision boundaries because there is a massive buildup of friction and pressure. However, no plate is being destroyed. Magma is not being created, so you don't get volcanoes. So as you can see, these two plates come head on, and they don't really sink into the mantle like oceanic plates would, but instead they just crash on head on, and they form these little fold mountains. But there's no magma involved, so not a volcano at all. Conservative plate boundary. A conservative or a transform boundary happens when two continental plates move alongside each other. Because plates are not being forced up or down, there are no major landforms found at these boundaries. Also, because crust is not being destroyed, no magma is being created, so there are no volcanoes. However, there can be huge buildups of pressure between the two plates, so massive earthquakes do occur. The most famous conservative plate boundary is the San Andreas Fault, where the North American and Pacific plates are moving along, past each other. Okay, so you can see here are two plates. This one's going that way and this one's going that way. And yep. Earthquakes and definitions. What's an earthquake? Any movement in the Earth's crust. Thousands of earthquakes happen every day, but most are so small that they are not even felt by us humans. Magnitude. This means how strong something is. Earthquakes are normally measured on the Richter scale. What is the Richter scale? Well, it's a normal scale used to measure the magnitude, so the strength of an earthquake. It goes up to 10, although the scale is effectively endless. The strongest ever recorded earthquake was a level 9.5 off the coast of Chile in 1960. The recent Japan earthquake from 2011 was a 9.0. Hypocenter, so the focus. This is the actual location where an earthquake takes place. The focus is always underground in the crust, so it's where it first comes from. Epicenter, this is the location on the surface directly above the focus. And the aftershock, this is an earthquake that can happen after the main earthquake. If the initial earthquake is so strong, then the aftershocks can be very strong as well. Japan had several aftershocks of over 7.0 since the initial 9.0 earthquake. So, secondary hazards. What is that? Well, it's a hazard that is caused by a primary hazard. Secondary hazards can sometimes be more dangerous than the primary hazard. So, earthquakes can cause several secondary hazards that can often be more damaging than the primary hazards. For instance, tsunamis, dam failures, landslides, fires, disease, exposure, liquefaction, etc. Earthquakes are extremely hard to predict because they give no warning, and the first earthquake is normally the strongest. Scientists, or for earthquakes we call them seismologists, look at earthquake history and attempt to identify plate pressure points to ascertain where earthquakes are likely to happen, but they can't predict how strong they will be or where they will happen. So, living near earthquakes. There are many places where people live in tectonically active locations like Japan, San Francisco, LA, Central America, and Chile. People living in tectonically active locations for a number of reasons. Well, they live there for a number of reasons. Well, firstly, poverty. Some people are very poor and are forced to live on marginal land that is very vulnerable to the impact of earthquakes, simply because they can't afford to leave. Inertia. Some people have lived in earthquake zones all their life and are unwilling to move. Infrequency. Major earthquakes happen relatively infrequently, so not very often, so some people are prepared to take the risk and don't think that one will occur in their lifetime. Overpopulation. Some countries are very densely populated, so people are forced to live on dangerous marginal land. Building design. Building design has improved, and now people are confident that their house or workplace will withstand strong earthquakes. Education and preparation. Many countries practice earthquake drills and evacuation and prepare their houses so they do feel confident that they will know what to do in an earthquake. Economic opportunities. Many tectonically active locations have good resources and locations, for instance, next to the sea. Because of this, there are many job opportunities which people will move near to take advantage of. So, the effect of an earthquake the effect that an earthquake has on humans can depend on numerous human and physical factors. These factors include, firstly, the depth of the earthquake, the magnitude of the earthquake, the duration of the earthquake, the local geology, is it soft or hard rock, solid or cracked, the location of the epicenter, is it in a rural or urban area, the population density around the epicenter, the building design and hazard mapping near the epicenter, the time of the day, because earthquakes at night might trap people in their houses, and earthquakes during dinner time might trigger more fires, etc., etc. The preparedness of the population, do they have evacuation routes, emergency services, etc. So, volcanoes. Volcano, a crack or hole in the Earth's surface that allows magma, ash, gas, or steam to escape the surface. Magma, melted, which means melted, rock under the crust. Lava, molten rock on the surface of the crust. So inside the earth it's called magma, and on the top of it, so where we live, it's called lava. Crater. This is a giant hole left by a volcanic eruption. Craters sometimes fill with water to make crater lakes. Magma chamber. An underground store of magma. A vent. This is a long tube or pipe that allows magma to escape the surface. Viscosity. This is how thick something is. If you describe lava as being viscous, then it means it is thick, so it's not like a super liquidy. A volcano that is currently releasing lava, ash, or gas is called an erupting volcano, because it's, erupting. An active volcano is a volcano that has erupted recently, and a dormant volcano is a volcano that has not erupted in recent history, but may erupt again in the future. A way to remember this is dormir, which means to sleep in French. So it's sleeping, but it's gonna wake up, and that's representative of it erupting again. So, what are some hazards of volcanoes? Well, firstly, lava flows, most traditionally associated with volcanoes, but probably one of the least dangerous hazards to humans. Lava flows only travel up to a couple of kilometers per hour, so it is possible to move out of their way. However, they can bury and incinerate any land or property that they travel over, so it can destroy land or your house or anything. Pyroclastic flows. These are giant clouds of ash and gas. They are extremely dangerous because they can travel up to 500 kilometers per hour and reach distances of nearly 30 kilometers, and they can be over 700 degrees centigrade in temperature. They will burn, knock over, or bury anything in their path. So it's extremely dangerous. Lahars. These are a secondary hazard and normally occur on snow-covered volcanoes. Hot ash and gas melt the snow and then mix. They then travel down the volcano as fast-moving mud flow, which can drown or bury anything in their path. Ash clouds. Not as fast-moving as a pyroclastic flow, but ash clouds can still be very disruptive. The weight of falling ash can collapse buildings and destroy crops. They can even reduce sunlight by blocking out the sun and even cause problems for air travel, like the recent Iceland volcano. Remember? It was a few years back now when all airplane stuff was stuck and no one could use an airplane. So, lava or volcanic bombs, or called tephra. When volcanoes erupt, they often throw out semi-molten pieces of rocks. As long as humans are a safe distance, they don't really pose any problems. However, because of their heat, they can start fires. Poisonous gases. When volcanoes erupt, they can release poisonous gases like carbon monoxide and sulfur dioxide. These can kill humans or even animals if they are too close, but they can also contribute to the greenhouse effect. So, volcanoes are a lot easier to predict than earthquakes because they normally give some warning signs. Scientists, in this case they're called volcanologists, will look for some of the following changes to try and predict a likely volcano. The change in the shape or size of a volcano, the change in the temperature of a volcano, a change in the amount and type of gas being released, earthquake activity, changes in plant and animal life, changes in local hydrology, for instance temperature and chemical composition of nearby rivers, yada yada. So living near volcanoes. Though volcanoes are extremely hazardous places, many people do choose to live on or near them. Some of the reasons why they do this include their beauty. Places like Mount St. Helens are beautiful to look at and enjoy. Minerals. It is possible to mine minerals like sulfur from volcanoes. Geothermal potential. Cheap and clean renewable energy, for instance in Iceland. Tourism. Tourists like to view and walk up volcanoes like the ones in Italy, like Mount Etna or Vesuvius. There is often hot springs near volcanoes, which tourists and locals can enjoy, like in Costa Rica. Land around volcanoes is very, very fertile because of all the minerals. Therefore, many people choose to farm the land. And poverty. People simply can't afford to live anywhere else apart from the marginal line on volcanoes. Complacency, which means they don't really care, or naivety, when they're so naive, because the volcano hasn't erupted for a long time, so people might think, oh, it's not going to erupt again for now. confidence that they will be given adequate warning to evacuate. A family home. Families have always lived in the area and perhaps it has sentimental value, so they don't want to leave. Shortage of space and high population density. If there's not enough space for them to live and there's too many people, well, it's the only place they literally can live then. So, what are some ways that you can prepare or react to volcanoes? Well, diversion channels. On some volcanoes, it has been attempted to make diversion channels to direct the lava away from settlements. So this is very expensive and hard because you can't predict in which direction the lava will flow. Cooling lava. In Iceland, in the past, they have tried spraying seawater onto lava. The idea was to make the lava go cold and turn into rock before it destroyed nearby settlements. Sweeping roofs. During ash showers, it is very important to regularly sweep roofs. If this is not done, the ash will get so heavy that it will eventually cause the buildings to collapse. Making evacuation routes. It is very important to plan evacuation routes for individual houses and whole settlements. It is also important to regularly practice these evacuation routes. So have drills. Exclusion areas. If an eruption is happening or likely to happen, it is important to create exclusion zones. This means evacuating everyone that could be affected by the eruption. Because pyroclastic flows can travel up to 30 kilometers, these exclusion zones can be very, very big. Hazard mapping. It is important to map the most dangerous areas near volcanoes, so areas with the most unstable ground or areas where lava flows are likely to travel. Once you have mapped dangerous areas, you can then stop settlements being built on them. Monitoring volcanoes. Because volcanoes do give warning signs, it is important to monitor them carefully so that you can warn nearby residents. You can also look at volcanic history. So as part of monitoring the volcano, you can look at its history and previous flows. You can then try to calculate frequencies in areas likely to be affected. Volcanic plug. You can attempt to make an artificially volcanic plug by dropping boulders or concrete into a crater or vent. This is dangerous and unlikely to be successful. In fact, it might even build up pressure in a volcano and cause a more violent eruption, but you know. Preparedness and vulnerability in MEDCs. Well, many more economically developed countries do hazard mapping and zonal planning. They will assess the risk for different areas of the country. So whether it's less likely to be a flood or, it's likely to flood or be in a lava flow, then they won't really go there. They will then only allow low value and low risk land uses in hazardous areas. Most MEDCs have fairly strict building codes to protect against earthquake damage. Buildings will have to be reinforced, have shatterproof windows, dampers, sprinklers, and escape routes. In MEDCs, the entire population will be educated about hazards. They will know what potential hazards there are and how to respond to them. People will be told evacuation routes and where safe areas are. Emergency and rescue services will be trained so they know how to find victims and how to treat them. They will have proper equipment and carry out practices. Hazards will be better monitored in MEDCs. Scientists will study volcanoes, track hurricanes, and then try and make accurate predictions and inform the public. Transport and communications are usually much better. The population can be informed and is therefore more easily able to escape. There are likely to be more helicopters, which can be essential in search efforts where roads are damaged. MEDCs are simply richer, so they can afford to spend more money on training and preparedness. There will be stockpiles of tents, blankets, and food and water for anyone who lost their home and possessions. So, preparedness and vulnerability of LEDCs. LEDCs tend to have more informal settlements that don't follow building codes. This makes them more vulnerable when hazards hit. Many LEDCs suffer from rapid urbanization and uncontrolled growth of settlements on dangerous marginal land. Medical care will be poorer in LEDCs, and there will be less money spent on search and rescue teams. Many LEDCs rely on emergency aid during times of natural disasters. Emergency aid always takes several days to mobilize, which will usually cost many lives. Transport and communication will be poorer in LEDCs. Much of the population will not have access to phones, television, or the internet, so will not be warned about forthcoming natural disasters. If they do know, lack of adequate transport may make escape difficult. There will There will be a shortage of helicopters, obviously, so it's very difficult. There probably won't be adequate supplies of tents, blankets, food, and clean water either, and services like electricity and water will take longer to repair, leading to the secondary hazards of diseases and exposure. A lot of population will be illiterate and never taught about potential natural disasters and how to respond to them. Less money will also be spent on monitoring potential hazards because countries have less money and less trained scientists. Also, evacuation routes may not exist and there may be a shortage of shelters. Poor LADC cities often have very, very high population densities. This causes more people to be affected by the primary and secondary hazard. Building design and preparedness. So, buildings can be made safer in a number of ways. Firstly, they can be built in areas less vulnerable to hazards, like on flat land with solid rock. They can then be designed to be made stronger, cross braces, and can be used to make the building stronger. Dampers can be added to high buildings to counteract the swing in earthquakes, or even springs can be added to the foundation to allow buildings to move. Once a house is built, pictures can be secured to walls, windows reinforced, and emergency exits created. Read the attached... No, don't do that. Never mind. So, short-term effects of natural disasters. Death. There will often be large numbers of people who have been killed in the initial disaster. This will obviously lead to grieving families, but also the bodies need to be cleared before disease starts to spread. Injury. Many people will be injured in the initial hazard, and these people will need to be treated. This uses precious resources and costs money. Panic and fear. After a major hazard, people will be scared of a repeat disaster. For example, earthquakes usually have aftershocks, which can cause further buildings to collapse. Secondary hazards. Short-term secondary hazards like fire might damage large areas or even kill more people after a disaster. There may even be further primary hazards like aftershocks. Infrastructure damage. Electricity, water and transport and communication links will all be damaged, which will hamper search and rescue efforts, leading to further secondary hazards like food shortages. Long-term effects of natural disasters. Homelessness. Destroyed homes can take months and even years to rebuild. Unemployment. Many industries and businesses get destroyed during disasters, so people lose their jobs. However, some jobs will be created in rebuilding efforts. Dependency. Countries who have suffered a disaster will normally see their income decline. This makes them more reliant on international aid and foreign countries. Long-term injuries. Some injuries can take months or even years to heal. It should be A, not EE. Like fractures and paralysis. Therefore, some victims will need long-term care. Disease. A major secondary hazard is often disease. It normally starts because of dirty and temporary living conditions as well as dirty water. These effects can go on for years until houses are rebuilt and water reconnected. Post-traumatic stress disorder. People who have experienced disasters or lost loved ones will experience psychological problems long-term. Rebuilding costs. Eventually, roads, houses, and businesses will all have to be rebuilt. This is very expensive, and the money will have to be diverted from other areas, such as education. And countries may also have to raise tax or go into debt to pay for the recovery. Infrastructure damage. A lot of infrastructure will be damaged long-term, making the recovery very hard. So, countries who have suffered disasters find it hard to recover because of the amount of death. So many people would be killed so that there are less workers and less money being generated. Injuries. So many people are injured, some with long-term injuries. So there will be, again, less workers. And there will be more need for money to be transferred to treat the injured people. Damaged transport links. Roads, ports, and airports might all be damaged, so people will find it harder to travel to work, and the country will find it harder to import and export. Damaged communications. Phone lines and internet links are often damaged during disasters, and communications remaining are often overloaded. Without communications, many businesses find it very hard to operate, and governments will find it hard to coordinate recovery efforts. Loss of income. Because businesses will have been damaged and there are less workers, the country will fall in income, so we'll have less money to spend on recovery. Psychological impacts. Many citizens will still be fearful of further disasters, so are too scared to return to work. Others will be grieving for friends or relatives, so are unable to work fully. Shortage of food and water. Food production and water supply are often affected by disasters. This can lead to illness and also malnutrition, so weakness from shortage of food. or too much, but in this case it would be too little. If you have weak and ill people, the recovery will be slower. Electricity shortages. Electricity generation and supply are often damaged during disasters. Most businesses, equipment, etc. need electricity to operate. If there is no electricity, then the recovery will be slowed. Damaged equipment. Equipment as well as people and buildings can be damaged in disasters, e.g. diggers or cranes. If equipment is damaged, then it will need replacing before it is possible to rebuild. Damaged buildings. Many buildings, including important power stations, hospitals, and governmental buildings, can be damaged. So if you're lacking power and important administrative centers, then the recovery will be made harder. So now some case studies. Why do people live close to volcanoes? Use the one in Italy, the Mount Etna volcano. The fertile volcanic soils support extensive agriculture with vineyards and orchards spread across the lower slopes of the mountain and the broad plain of Catania to the south. They can also generate electricity from the volcano using geothermal power. The volcano attracts tourists and of nearby Messina and Catania, and so they earn money from renting accommodation to tourists. Also, the Italian government has invested a lot of money in prediction, and they are willing to take the risk. Sentimental value, e.g. family has lived there forever, or they may not even be able to afford to leave. So now describe the impacts of an earthquake. We chose Haiti. On the 12th of January 2010, an earthquake measuring 7.0 on the Richter scale struck Haiti. 220,000 people were killed, 300,000 were injured. 1.2 million, that should say million, not just 1.2. 1.2 million Haitians were displaced. 8 hospitals in Port-au-Prince, which is the capital, were destroyed. 200,000 homes were damaged in the Port-au-Prince area since infrastructure is poor, and the houses stood on steep hillsides, vulnerable to collapse. The main shipping part was badly damaged, and part of it collapsed into the sea. Many government buildings, including the presidential palace, were destroyed. Roads were blocked by fallen buildings and smashed vehicles. Over 2 million Haitians were left without food and water. Looting became a serious problem. The destruction of the government buildings hindered the government's efforts to control Haiti, and the police force collapsed. The Haitian tourist industry declined as tourists stopped visiting, and frequent power cuts, and by 2010 there was a cholera outbreak. And the damage to the port and main roads meant that critical aid supplies for immediate help and long-term reconstruction were prevented from arriving or being distributed effectively. Last one, causes of an earthquake. We're just going to look at San Francisco. So the San Andreas Fault was the line of weakness. The North American and Pacific plates are moving at either side of the fault, so along each other. And then plates become locked together, so friction prevents smooth movement of plates. So then there's a buildup of pressure, then there's a sudden movement, which will make the plates jerk apart and create the earthquake.